Day, grade 11s. Welcome to another video with your boy Sizwe Makalemele from the University of Pretoria. In this video and the next, we will be discussing functions, graph of functions in grade 11. So in this video, we'll be looking at ways of tackling a question paper, a final grade 11 question paper where the question is based on functions. In today's exercise, we'll be doing this question paper, which is question 5. Question 5, they give us a hyperbola and ask us to answer those questions in section 5.1. And in 5.2, we are given an exponential function and some questions, and then in question 6 we are given another functions, two parabolas, one smiling face and one with a sad face. And then lastly, question 7, we are given two functions, one of which is a straight line and another is a parabola. We will be answering those questions, question 5, 6 and 7 in this question. Starting with question 5. So, how do we come about solving function problems? In question 5, this is question 5. This is question 5 of the final exam. So we are given a sketch. This is a sketch of a hyperbole, and the hyperbole has this formula: f of x is equal to negative 9 divided by x minus 1 minus 2. So the first question here asks us to write down the coordinates of A. A is this point, and we are asked now to write down the coordinates of this point. So can you see where this point A is situated? It is situated where the asymptotes of the graph intersect. This is the point where the asymptotes, this is the x asymptote, where the x asymptote intersects with the y asymptote. So the asymptotes are easily identified from the equation itself. So from the equation we can see that this here is your x asymptote and this here is your y asymptote. So you use this expression here as your x asymptote and you use this as your y asymptote. So the answer for this question you need your x asymptote, which is x is equal to 1, and your y asymptote is y is equal to negative 2 from this parabola itself. So in point coordinate form, we find that it's 1. The point A is 1 and negative 2. Are we happy, guys? Are we happy on how we got our asymptotes? It's the number for x. You want to solve it. For x, it's actually x minus 1 is equal to 0. This denominator, you take the denominator and you set it to 0. And then after that, you solve it to get by pushing the 1 to the other side, so you get that x is equals to 1. And then the second question, they ask us to write down the coordinates of the x-intercept and the y-intercept of f. So I'm going to start with the x-intercept. The x-intercept is where your y is equal to 0. So if y is equal to 0, it means that this function, this whole function by itself is equal to 0. So negative 9 over x minus 1 minus 2 is equals to 0. So this is your y-intercept. It means the whole function is equals to 0. You want to solve for this. So you want variable on one side and numeric on the other side. So it's negative 9 divided by x minus 1 is equals to 2. Since we don't like fractions much in maths, we're going to multiply by x minus 2 both sides so that this can cancel. X minus 1 both sides, so that can cancel. So here you're left with negative 9, and then here you need to distribute in so that you can get 2x minus 2. We are looking for solving for x, so you want x on one side and numerics on the other side. Negative 2x is equal to positive 7. It's equal to positive 7. Hence, x is equal to negative 7 over 2. Are we all fine with that, guys? Or you can't see. Since negative x is equal to 7, we can divide by 2 both sides so that we can get x being equal to that. And now for the y-intercept. For the y-intercept, we know that x is equal to 0. So y is equal to negative 9, 0 minus 1 minus 2. You can punch all of this into the calculator. You will get 9 minus 2, which is equal to 7. So your coordinates, your x-coordinate intercept is 7, 0, and then your y-intercept is 0 and 7. Are we all fine, guys? All happy? And then the next question we are asked to write down the equation of the axis of symmetry of f that has a negative gradient. So we need to find a line of symmetry of the function. How do we find the line of symmetry of a function who is a hyperbole? So a hyperbole, we know that it is a function that is equals to some constant divided by x plus some constant plus another constant. This is a function of a hyperbole. And if you want to find the line of symmetry or the axis of symmetry of this function, you would need to use these numbers, this expression, this one and this one, to find the line. So your line is equal to x plus b plus q. This is the line of symmetry. This is the equation for the line of symmetry. But now our question wants this axis of symmetry to have a negative gradient. So if it has a negative gradient, it would mean that the line, let's make it a function of y, who is equal to a negative gradient, but you see use the same expression. In our case, we know that b is equals to -1 and q is equals to -2. So our line is -x. We distribute the negative in here, get +1 minus 2. So y is equals to -x minus 1. And there you have it. That is your axis of symmetry that has a negative gradient for our function of f. Now, in the next question, we are asked to determine the coordinates of some point that's on the function, but it lies in the fourth quadrant and it is closest to point A. So we want a point somewhere in the fourth quadrant. It's on the function and it's closest to A. We know that our line of symmetry passes somewhere here because it passes through to A. No, we're not sure if it's close, if it passes through this point A, but we know that it passes somewhere around A and then through to our function. So if we want a point that is closest to A, but which is onto the function, which means it must be on this line of symmetry. So in actual fact, we want to find where the line of symmetry intersects with our hyperbola. So what we're going to do for this question is we want to find where f of x is equals to its line of symmetry. So we write the equation for f. Write the equation for f. It's equals to this line of symmetry of itself, which is that. So we want variables on one side. So you have this expression here. We want to move this 2 over to the other side, so it must be positive when it gets there. -1 plus 2. So minus 9x over 1 is equal to -x. -2 minus 1 is 1. So now what we want to do is, we don't like fractions when we are solving for x. So we're going to multiply both sides by x minus 1. Multiply both sides by x minus 1 so that this can cancel out. We have -9 here, and then here we want to FOIL out. You want to distribute both. So here you get -x squared plus x plus another x minus 1. So this clearly looks like a quadratic equation. So we want to move each variable all to one side. So x squared plus 2x minus 8 is equals to 0. So here we want to factorize. So x here, x there. We want factors of 8 that when you subtract give you 2. It's 4 and 2. We want to minus here and the plus here. X is equal to 4 or x is equal to 2. So we find the x coordinate. Now we need to find the y. We know that y is equal to -x minus 1. Oh no, I'm sorry for being so quiet, but I've spotted a mistake here because these two eggs, when you add them together, it's 2x, and when you go that side, it's going to be a negative. It should be a negative, guys. Check my work. It should be negative. So, which means when you're doing your factors here, the bigger factor gets a negative. And the smaller factor gets a positive. So which means x is equals to 4 or x is equals to -2, right? This is not a solution we're looking for because we want something on the fourth quadrant, which means x must be positive. So x is equals to 4 is the correct answer, and then for y we want to substitute positive 4 into x and we get -5. So the closest point that you can have on the function that is closest to a in the quadrant is 4 and -5. And that's it. The next question says, the graph of f is reflected about the x-axis to obtain some graph g. Write down the equation of g in the form of y. So they say that g is found by reflecting f about the x-axis. So if you reflect x about the x-axis, it means you're making it negative so that you can find g. So negative of our function, which was -9 over x minus 1 minus 2, we get that g is equals to 9 over x minus 1 plus 2. And there you have it. G of x is equals to 9 over x minus 1 plus 2. Right? And that's it. But you can't see, right? You can't see. What I was doing here was trying to find the reflection of f about the x-axis, which means you make x negative to find g, which is a reflection of f about the x-axis. Make the whole of f into, you substitute it in. When you want to substitute in the f, use brackets because you're substituting f. Substitute f inside brackets, put the negative sign outside, and then you simplify so that you can get g. When you simplify, you distribute the negative inside. Negative times negative is a positive, and negative times negative is positive. That's why g is found to be like this. And now we move on to question 5.2, where we are given an exponential function. So this exponential function's name is given as h of x, who is equals to 4 multiplied by 2 into minus to the power of minus x plus 1. So in this question, the first question they want us to find the coordinates of the y-intercept. We are required to find the y-intercept of this function. So the y-intercept is found if x is equals to 0. So y is equals to 4, 2 to the power of 0 plus 1. We know that anything to the power of 0 is equals to 1 plus 1. So then this is 4 plus 1 is 5. Are we happy, guys? That is the y-intercept of the function. So in coordinate form, this is what we would have. And now the next question, we are asked to determine whether we must explain, rather, we need to explain why this graph H does not have an x-intercept. Why it doesn't have an intercept? Okay, we can show this algebraically. If you want an x-intercept, it means that you want y to be equal to 0. So 0 is equals to 4 multiplied by 2 to the minus x plus 1. So right, which means 2 to the minus x is equals to negative 1 over 4. But this is not possible. This is not possible. It's not possible. Why am I saying this is not possible? Picture the graph of y is equals to 2 to the minus x. This function, it passes here at 1, but it is always positive. It's never less than 0. This function is never less than 0, which means this function cannot have x-intercept, because this expression 2 to the minus x is always bigger than 0 for all x being an element of real numbers. So this expression can never be satisfied because this function is always positive. You understand? So moving on to the next question. The next question, we are asked to draw. We need to draw the graph of H clearly, showing all intercepts and intersections with the axis. So we need to sketch the graph of H. Showing all the asymptotes, intercepts with the axis, and at least one other point on H. So to draw this beautiful picture, we would need a Cartesian plane. So don't use a ruler, don't use a pen like me when trying to make a sketch. Rather use a ruler for accuracy. Remember, maths is about speed and accuracy. So you have this Cartesian plane, right? Which means here it's y and here it's x. So already you have your y-intercept. Right about so high at 5. And then we have our horizontal asymptotes at 1. We have our horizontal asymptotes right here at 1. And then this graph has the same effect as this graph. So it's just that it has a steeper gradient. And that's about it. So you have that, and now we're missing one extra point. So since this function exists everywhere, we can use any number of x. We can take any number of x. We can take like -2, and if you plug in -2 into this function, you will get an output of 17. So here you have it. We've given a sketch of the function, nice and neatly, and labeling everything that we have. And now, in the last question, for question 5, we are asked to describe the transformation from h to this function g. So this function g is equals to 4 plus 8. So if you check the difference between this function and h, the difference is the last term, which shows that this graph has been shifted. It has been shifted 7 units upwards. And that's it for question 5. Now moving on to question 6, where we are given this 2 beautiful parabolas and some questions. Without further ado, question 6. So we are given that f of x is equals to x squared over 2 minus 8. This is the function of f, and then also we're given the turning points of g at c. The y-intercept of g is y. So in this question, we are given this function of f, who's a parabola, and it's drawn on the same self-axis as g, who's also a parabola. So in this question, for question 1, 6.1, we are asked to show that g is equal to negative x squared plus 4x plus 5. We need to show that this is true. So how do we go about showing this? You can show this the simple way using the formula, the basic format of a parabola. So this is the basic format of a parabola. G of x is equal to a x. Can you see the turning point? You use the turning point now to find the equation for the function. So if you use the turning point, you're going to use the x value, and when you use its x value, use its opposite value. So it's going to be minus 2 all squared plus 9. So for b and c, you use your turning point, which is 2, 9, right? And now you can use this other extra point that we are given, another extra point that is on the function. So if you input 0, your output is 5. So 5 is equals We want to solve for a, so a is still unknown, but we know that if input is 0, we get output of 5. So 5 is equals to a multiplied by 2 squared is 4 plus 9. So variables on one side and number and numerical values on the one side. So 4a is equals to 4. Hence, it's negative 4a because the 8 goes there, moves to this side, and then the 5 goes that side. That's why it's subtracted 5 from 9, which is 4. We get that a is equal to negative 1. So the equation of g of x is, we know that is a multiplied by x minus 2, so we can substitute the a as negative 1 there. X minus 2 squared plus 9. So this is the equation for this parabola G. Need to open it up so that it looks the same as this one. So how you open it up is, you square the first term. 2 times the first term times the second term is 4x, and then you square the last term. Add the 9. Simplify this, you have to distribute the negative inside. Negative x squared plus 4x minus 4 plus 9. So we get the negative x squared plus 4x plus 5. Exactly as what it was shown. As required, what was to be shown, we done. And then question 2, we need to calculate the average gradient between point A and C. So we need to calculate the gradient between these 2 points. We know that the formula for finding gradient, we know that it's m is equals to the change in y divided by the change in x, right? So what do we have here? We have that 9 minus 5 is divided by 2 minus 0 due to the points A and B. This is equals to 4 divided by 2, which is equals to 2. And that is your gradient. And then now, the next question, we are required to find the length of bit from B to D. Take note that the 2 points B and D are the x-intercept of the graphs of f and g respectively. So to be able to find the coordinates of B, you would have to find the x-intercept of this function. In a similar way, to find D, you would have to find the x-intercept of this function. So how do we find x-intercept of a function? We need to let the y be equal to 0. So if y is equals to 0, we can then say that we have found our x-intercept because our y is 0. So question 6.3, first gonna find D, which is the x-intercept of the graph of G. Which is the x-intercept of the graph of G. So you must make y to be 0 in g using the function of g. So 0 is equals to negative x minus 2 all squared plus 9. So we need to calculate the distance between b and d, but before we can do that, we must first find the x-intercept of both functions. So we know that the x-intercept is where y is equals to 0, so we're going to have to solve for this equation. So the 9 jumps over to that side, so negative 9 is equals to negative x minus 2 all squared. So divide both sides by negative, and then you square root to find x. So plus or minus x minus 2 is equals to x, it's actually x minus 2 is equals to plus or minus 9. So x is equal to plus or minus 9, square root of 9 plus 2. So x is equals to 9 plus 2, or x is equals to minus 9 plus 2. So x is equals to 11, or x is equals to no. From there to there, it's a mistake. From there to there, it's a mistake, because we know that the square root of 9, is equals to plus or minus the square root of x minus 2. So it's going to be 3 is equal to plus or minus x minus 2, since the square root is going to cancel out. So now, if you want to solve for this, you know that plus or minus x minus 2 is equal to negative 3. So x is or positive x minus 2 is equals to negative 3. So what do we get here? We get that x minus 2 is equals to 3, so x is equals to 5, or x is equals to minus 1. This is for the graph of G. These are the x-intercepts of the graph of G that can show us the point D. But as you can see here, that the point D is lying in the positive x-axis. So the best solution for D in this case is the one with the positive x, which is positive 5. So point D is at 5 and 0. So we know that here we made a mistake, but we found the point D to be at 5 and 0. Now we want to find the point D. To find the point B, you would need to find the x-intercept of f. So y is equal to 0 for f. So what you're going to do here is you're going to set f to be 0. So we know that f is equals to x squared over 2 minus 8. So you're going to set that to be 0. So x squared over 2 minus 8 is equals to 0 if x squared over 2 is equals to 8, which means x squared is equals to 16. So x plus or minus square root x, get that x is equals to plus or minus square root 16, which is equals to plus or minus 4. So x is equals to 4, or x is equals to negative 4. So if you looked at the functions, you would see that b is in a position where x should be negative. So this is not a solution. So point D is at negative 4 and 0. Point B. Point B is at the point where it's negative 4 and 0. As you can see from the graph above, that the distance between B and D can be calculated by adding the distance from BO adding the distance at BO with the distance at OD. The total of that sum will give you the distance of BD. So since we have both the coordinates of B and D, we can do this as easily as possible. Since they are the x-intercept, we have found their coordinates, and now we're going to use these coordinates to find the distance between these 2 points. So we know that BD is equals to BO plus OD, which is equals to 4 plus 5, which is equals to 9. As simple as that, guys. That was the distance for BD. And now, next question is telling us to use the graph. The next question, we're going to do it on this little box here. So the next question says that number 1, we need to solve for x. We need to find the values of x where f of x is bigger or equal to 0. So you want the graph on this point where f is above the x-axis. And where is it this condition satisfied? From B, this condition is satisfied from B going to negative infinity. Can you see that? And also this condition is satisfied from this point to positive infinity. So what are we going to use here? What are we going to use? We're going to use the intercept of, we see here that it's positive from negative infinity until it gets to B. We know that the coordinate of B is negative 4. So we include this, and also from 4, because we know that this graph x-intercept is at minus 4 and 4. So it's from 4 to positive infinity. Right? That's when the graph is positive. And then question B is asking us where both F and G, both F and